trying to do their initial learning from that. So now we're finally getting into some real operations of linear algebra. And the lecture links for his videos and the section link for vector dot product dot and cross products. I'm getting that ready right now. Just copying them over here for you guys. And you know what I appreciate about Saul? He sometimes will share about his academic past, his interaction with his professors when he was learning this stuff. But we won't get all the way to cross products today, but we'll get to some important things. And there's a fun thing that I got to do for y'all in preparing for this that I'm eager to show you. So here's our math, and I hope you'll play with the latex. That is the latex math. But let's look through it. First, just vector dot product and vector length. And I'd actually forgotten you could do this. It was really good to rewatch it for myself. But if you have two vectors and they're going to have the same dimensions for this to work, the dot product's just the sum of the products of their individual elements or components. So here we have x1 through xn for the x vector, and y1 through yn for the y vector. And the way we get the dot product is just to multiply element-wise, but then to add up those products. And we could have put equals a sum symbol from 1 to n of xi times yi. So that would be a fun exercise for the student. And but this is also a very cool property of dot products. If we want to find the length of A, that is the magnitude of it, well, it's just the square root of the dot product of that vector onto itself. So vector A times vector A dot product, that is, and then take the square root. Well, look, that's just what we would have done anyway. A1 squared, A2 squared, A to the n squared. But let's note this, let's remember this. When we're taking a dot product, we get a scalar value. Later, when we take a cross product, we get a very unique vector. So again, dot products yield scalars, cross products yield vectors, but they actually point outside of the plane that the two vectors created when we do a cross product. But we don't have to talk about that today because we probably won't get that far. And I'm hoping that we can even get into a demonstration of visual Python. So I am going to, I have to do it this way. All right, and let's this one down here. So let's look at that in a mathematical way, in a coding way. Okay, let's say V1 is just 1, 1, and V2 is 2, 2. Now, from our visualization work, you guys can already probably imagine that V1 is just laying on top of V2 and V2 is extending beyond it. But if we take the dot product, V1 dot V2, it's going to be some scalar, and that's just V1 0 times V2 0 plus V1 1 times V2 1. And we'll run this cell. And notice we didn't even need to import anything because we're just using pure Python here. But what if we were to make a pure Python function of this? Let's do that. Now, I invested in this speed typing course, and I can't tell you how valuable that was. Can you believe how fast I typed that? No, seriously, I'm cutting and pasting. So now I'm just defining those again. But
Okay,
this
sorry,
time,
sorry. That I think there's a question in the chat.
yes, good question, Kareem. Do we lose direction information when we do dot products? Absolutely, because it's not a vector. By its very nature, a vector gives us magnitude and direction. And in this case, right now, it's by the fact that we have information in each direction. We could say that this was along the x-axis and this along the y-axis, but we could have a huge number of dimensions in real space. We're just playing with two-dimensional space for simplicity. And here we have in the x and y direction, but you're absolutely right, Kareem. We have lost direction information, and we can call it a magnitude, but we call it a scalar instead, just to be very distinct. So thank you for asking that. Now, what I wanted to do in this definition, because I'd like it to be reusable, I want it to fail if the length of VA and VB are not the same, because they have to have the same number of dimensions. And then what this assert statement does is it says assert that these lengths are equal. But over here, this message is given if they are not. The vectors are not the same dimension. And so VA, we start this way. We're going to sum up along each dimension. And I'll get to the new question here in a minute. VA dot VB equals 0. And then for I in range length of the first vector, and I already know that they're the same length because I couldn't have gotten past this assert statement. VA dot VB plus equal VAI times VBI. Now, what's happening here? It's just saying, well, if we expand this, that this is a shorthand way of just saying, be constructively lazy. There we go. Now I've been constructively lazy. It was a shorthand way of saying that. And what are we going to add this to? To 0. So that's just so that we can have something to total as we go along the dimensions. And again, we could send in something with thousands of dimensions here. So once that's done, we just return that. And what do we expect? 4. Because it's 2 plus 2. 1 times 2, 1 times 2 again plus 4. Now, let me look at the, psi. Okay, good. I see what you did, psi. If the 2 scalar value represents x and y direction, no, so, yes. But I don't know what you mean by the 2 scalar value, but when we get a scalar value, you're right. It represents the projection of one vector onto the other. That is absolutely correct. We're going to get into that another time, but I'm glad you're thinking ahead, Sai, because that means you've had some linear algebra training in the past, so that's awesome. Let me take a little drink, guys. Nice. All right. Now, but we also want to be good at getting to know NumPy, right? So let's do that. And we've got a, when we use modules, I like to show how to do things with the least lines possible. So I've done this all in one line. My alias for NumPy dot V1 and V2, and I'm using the same V1 and V2 from up here, but boom. So that's the NumPy way to do a dot product. Now you might be thinking, oh, what, these were Python arrays, and you just set them in. Yeah, NumPy can deal with that, but if you were being extremely pure and you wanted to be, you know, just make sure you converted those to NumPy arrays for later operations, you would do it this way. Now here, they won't be preserved because I'm doing a one-time conversion, but you could call this V1 NumPy or something like that. But just to show you, it works either way, same thing. Now, one last thing, we talked about getting the length of a vector using the dot product, like using it in place of squaring the vectors. So that's what we're doing here. We've got a 3, 4 vector. Now we know if we're going to look for the magnitude of that, we know because of the law of 3, 4 triangles, and these are orthogonal, so they would be the legs of a triangle. We're just going to get the length of this VA. But how? Well, first, we take, again, the dot product of it on itself, but then from the result of that, we take the square root. And this is just my shorthanded way to get the square root. I raise it to the 1/2. And boom, we get what we expect. So very simple. This is one of the more basic operations in linear algebra between two vectors. And we could do it through multiple vectors, but typically we are thinking of the projection, thank you, Cy, of one vector onto the other. And that's something in a near lecture we'll go ahead and visualize, since Cy brought it up. Or you guys can work ahead and find out a clever way to do this in Matplotlib. So we'll see. Okay, then Saul talked about this weird inequality property that's popular among those that do the fine arts of linear algebra, the Cauchy-Schwarz inequality. Well, that's interesting. What does that mean? Well, let's do some more speed typing. Now, I'm not going very fast right now, but here we go. Boy, that's fast. Okay. So what is this telling us? If I take the magnitude of one vector, x, and the magnitude of another vector, y, and multiply them, that will be greater than or equal to the absolute value of one of those vectors dotted with the other. But now Saul does a thorough job of doing that in his lecture with algebraic proofs, which are beautiful. I will always love them. And a fun exercise for you guys is to completely plagiarize piece parts of my LaTeX and try to add to your versions of these notebooks that algebraic proof, but in LaTeX. That would be really cool if any of you want to do that. But let's do something a little different, since he already did the algebraic proof. And in the same spirit that he did proofs of spans and subspaces and bases of subspaces, well, remember how we would visualize a span, but in a finite sense. In other words, we used our imaginations to fill in the gaps, so we were just using integers and only within a certain range, but at least it gave us a feel for what it would look like. Well, This is some code I wrote in preparation for this, and I'd like to improve it before we go on. So I'm just saying Cauchy-Schwarz inequality for two vectors that I send in. And first, I use that same assert statement to make sure that they are equal dimensions. Then I go on ahead and use NumPy to get their norms, because we've done this without NumPy also. You guys know what's going on, and we just did it above. And then, so I get the norm of each of those. Let me show the inequality up here too. I get the norm of that's this one and this one, so we're good there. But then I need to do the dot product between the two, so that's what I'm doing here. And then I also need the absolute value. That's what these single vertical bars mean. And then because we're working with some big numbers, or we're working with the computer, sometimes we get what's called round off error. Even if we're just using integers, this can happen. So what do? I just go in and round it out to 6 places. That should be good enough. And this would actually even work for 9. But I'm going to say if the product of the norms is less than the absolute of the dot products, then that's the same as this. But I'd like to state it just like it is up here. So let's do that. We're going to just say, now you can see already why I did this, but what I'm going to, it's because, well, how do you say not that? And I'm going to show y'all a fun trick. So we're going to state it like it is up here. Oops. So that's exactly what we're seeing up there in the latex. In the right here, that is. Okay. I'm going to take this out and call it the check. Now, this is something I love to do to make my code easier to read. The check equals some Boolean value. In other words, when round of this is compared to this, the result of this logical operation here will give us true or false. And we'll just call that the check. Now, I could have done it with that stuff down there, but I'm just going to say now, if not the check, in other words, wow, if this wasn't always true, I want to print out this and look at them. And we're going to say from this function, return Cauchy-Schwarz inequality failed, else it holds. Okay? So we're setting up that function for more use. Now let's do something totally insane, which I do a lot of insane things, frankly. So, but I like doing them. Well, if they're safely insane, and this won't hurt anyone. Now let's think about what's going on here. Count equals 0. So basically, we're going to count up in this nested for loop system. And how many nests do I have? 1, 2, 3, 4, 4 for loops. Wow. And I'm going to go, my finite span is going to go from 10 to 10. Again, in these range statements, 10 would not be included, so I'm adding a 1 each time to include it. Now let's think about this. We're going from -10 to +10 with 0 included. So let's do this real quick. Code, and that's going to be 21 to the 4th. And because we're in a notebook, that'll just give us the answer. Okay, I see what happened. That doesn't mean what I meant it to mean. That's how you raise it to the 4th power. Okay, that means we're going to do 194,481 total comparisons. Now, it's not proving it for all cases, but I think it's safe to say it's proving it enough. So again, when it comes back, now here's where we're calling that function. And here are the vectors we're creating each time to send into that function. And we're getting back the result. If result doesn't equal this, we're going to say do not hold equals true. And we really should bounce out at this time, but there's all these for loops. So what can we do? I really don't like the way this is written completely, because if I say break right after this, well, it'll only break out of this for loop. But I only have this value set once. In fact, just to be extra careful, let's do this. And I'm going to show you how I'm going to make this more to my liking, is what I'm getting at. So the only way for it to go from false to true is for it to happen one time. There's no other way for this to get set back to false. And I want that, because if even one of these tests out of this almost 200,000 tests fails, I want to say it did not hold, and then I want to send this. Now we're going to change these, order these real quick. So if it did not hold, print this, and it only has to fail once. Otherwise, it stayed false the whole time, and we get to see how many counts it held for. So how long do y'all think it will take? Yeah.
I think there's a question, Noreen.
Okay, I'm not hearing.
She has her hand raised.
Oh, go on ahead, please.
Yes, please go ahead.
Yeah. Hi. Assalamu alaikum. How are you? In the
Good.
above
How are you?
functions which you are writing, in the above code, you have said if not. Why you have given that negation there? That's what I was like, confused about.
Right
in the
here?
above block.
Yes.
Yeah.
Yes.
Yeah. It's
So,
not the
yeah.
check.
Very good. So what I'm doing is I'm saying, okay, this is what I want to always be true. And this will return true if it's true and false if it's not. So I just store that Boolean in a variable. And then I say, if it's not true, I want to see what happened, and I want to return that it failed. But if it is true, the only other option is it was true, then return that it holds. And so I'm just saying, well, I want to state the theorem as it's written, and then I'm just saying if it's false. So in other words, if not, let's see. Yeah, I only want this to happen here if it was false. Otherwise, it holds. Does that make sense?
Yeah. Okay. I was thinking other way around, so that's why I got confused, right?
Oh no, I totally get it, and no judgment, because sometimes I have to think very carefully about these. Well, all the time. But the thing is
yes.
the cool thing I wanted to show you all here is that you can set a variable name and get a value assigned to it. That's a Boolean also, just like we have variables for strings, we have variables for arrays, we have variables for values, floats, and integers. We can have variable names for Booleans too, and that cleans up our logic statements. Now, here it wasn't so important, but if you had a bunch of different logic checks for an if statement, this can become very valuable. So I just wanted to introduce it there. It's a good code cleanup.
Yes,
Sure.
thank you.
Thanks. Yeah, thanks for the question. That's good.
Thank you
Oh,
very
and
much.
you bet. You bet. Now, be careful to ask the questions to everyone, but now I can't see all the names the way my Zoom is working in Linux, but was that you, dear Ridwan, that just asked that?
So that
This
was
is Noreen.
Noreen.
Okay, sorry.
Yes.
Thanks, Hugo. I just can't see all the names now. Ridwan sent me a direct
This is,
message.
I'm from the Isaka Muscat chapter, Noreen.
It's Noreen. Noreen saying no from Isaka.
Okay.
Yes.
Very.
Yeah, our
Thanks,
sister
Tom.
from, yeah.
Okay, very good. Very
Yes,
good.
thank you very much.
You're welcome. Now, but I'm sorry, I might have got confused with all that. Did Ridwan's question get answered? Because she's asked me, or he or she, forgive me, I don't always know masculine, feminine names in different cultures. I wish I did, but go on ahead.
It hasn't been answered. I sent you a private question. Sorry.
Yeah. Is it okay if I read it out loud?
Sir?
Is it okay? Is it okay to read it out loud?
Yes, yes. Thank you.
Okay, great. So explain the reason for the iteration and what's the reason for the negative VE sign for the finite span? Sure. All I'm saying is I'm going from -10 to +10. And this +1 is because in the range statement, the value for the final value is not included. It goes up right before it. And also, if you don't include the step size statement, it assumes it's 1. So here you go. You got start, stop, and then step. But again, if you only put one value in here, it assumes you want to start from 0 and go just before that value you entered, and it'll step by 1. Otherwise, you can give it a start value that's before 0. You can give it a final value and add 1, so it will include that final value. And then you could step by any size you want right here, but we're only stepping by 1. And you can't step by anything smaller than 1, although there is a type of range statement in NumPy that you can step by very small values with. Please let me know if I did not answer your question or if I did.
Finite span is 10,
It's just the reason we say finite span
Exactly.
is to.
Finite span is the positive 10, right there?
Yes. Correct. I'm just setting it so I don't, that way if I want to change the value, it changes for all of these. So
Okay.
that's the only reason to do that.
Okay.
But
Okay.
I'm just going from
Got it.
-10
I got
to,
it.
okay, good. From -10 to +10, right. Okay, good. And this is the fun thing. We get to get better at linear algebra while we're getting better with Python. And I hope y'all are seeing the value of that. But now we've got this function up here defined. Let's see if I can get this all in one screen. I think I can. Although we're going to have to scroll again here in just a second. You know what? I think I'll go just one step smaller. Is that okay for you guys? Hugo, do you think that's okay for everyone?
On my screen, I need to squint a bit, but maybe you could just
No,
increase the size.
I'm going to go back up. So
Yeah.
we'll show a little less of that. There's the main operations there. And then, oh, I know this was just a check. So let's delete that to get more real estate back. There we go. Okay, so now we'll finally run.
Sai has his hand raised for over 10 minutes right now.
And forgive me, Hugo, you have to help me because the way my screen is set up, I cannot see raised hands because I'm sharing my screen and I'm on Linux. So, oh, wait, I wonder if there's a way. No, it just, I need your help there. Sai, buddy, going ahead.
Yeah, I just have it out. Like instead of taking the norm and absolute value, can we see it like this, that whenever we speak of dot product, we have cos in it. So the cos value, the maximum value of cos is 1. So it will be always less than or equal to the absolute value, dot product. So can we write a function like that? Is it possible?
So I feel like that's what I've done.
Like,
So do you mean, could we have put this times this greater than equal to this directly? Like in one line?
I mean that VA, VB cos alpha, which will be always be less than or equal to absolute value of the VA and VB. And since cos alpha, as we know that the maximum value of cos is always 1. So it can't be, it will always be less than or equal to the absolute value, the dot product. So can we present it like that? That's what, using cos. Yeah.
Do you mean, could we have flipped this around? In other words, Sai, forgive me, I'm trying to understand.
No, I'm actually speaking about the expansion of the x dot y dot product expansion. X y cos alpha. So since
this part,
since we know that the dot product, whenever we speak of dot product, it has cos in it, cos function in it, and the cos function value, the maximum value can be only be 1. So it can't be. It will always be less than or equal to the absolute values of the x and y. That was what I was meant to say. Can we?
And you're saying the cost function.
Yeah, because whenever we speak of expansion of dot product is nothing but x, y, cos alpha, right? This is the expansion, standard expansion. Am I wrong?
It's just that I don't know. You're either saying something I don't know about or I've forgotten, but are you saying causal or cost?
I think I'll just
No. Type. Put a little bit of what you're saying in this chat, because I think it's probably important. You may be just asking something I don't know the answer to, which is always possible. But cosine of alpha. Yes. If you know the angle between these two vectors, then
cosine of.
Yes, and so, but also you've got to understand that is really the reason you want to be careful with that. Oh, hey, you too, Avinash. The reason you want to be careful with this sign is that really only works if you're dotting a vector. Let's say it's off of an axis, but you want to find the projection of that vector onto the axis. Well, that only works if this one, for example, is a unit vector. Then you could replace this with cosine of the angle between that unit vector and the vector that you're wanting to know the projection of onto that axis that the unit vector is along. So you got to be careful with that way, Sai. Otherwise, this is a bit different than cosine alpha. So how do I put it? It's yeah, you know what? I'm really glad you're already thinking that way, Sai, but I think we need to be careful at this point and come back to this we will definitely get to things like that in future lectures. Will that be okay?
Yeah, sure. I just was asking out of curiosity. Like, I felt.
Yeah, no, that's great, and everybody should take note. What Sai's asking, there is a relation between the angle. If we know the angle between these two vectors, which is another way to get direction relative to one another, and we take the cosine of that angle, it really does tell us something about this scalar value we're seeking. But also on cross product, It's the sign of the angle between the two vectors that we care about. So kind of like a little sneak peek to the future. Okay, let's finally run this guy. All right, now we're using Google Cloud servers, and let's see how long this might take and if I've made any coding errors. 6 seconds. And sure enough, it went the number of times we expected, and it held for all those tests. So this was a fun way to do what Saul did in his lecture with pure algebraic proofs, but do it with code. Now, Saul said something in his lecture about proving this. And this is the way a lot of mathematical proofs go. He did out the proof and he explained how, wait, it's really that simple. And his math professor was, yeah, we're wanting you to really just prove it to yourself the most elegant and simple way possible. But sometimes you look at the proof and you're like, but that's so obvious. Yeah, exactly. That's what you want it to be. So now on the other side of the spectrum, which is probably where I am with most math students that are first seeing this stuff, I'm like, what? Huh? So that, by the way, that's a very American way to say I'm totally in the dark and lost. Oh, I remember being lost so many times my freshman and sophomore year as an undergrad. But I made very good friends with one of my professors, my fluid mechanics professor. I said, you know what? I really felt like I was in a fog the first 2 years, but I kept working, I kept thinking, and then it's all starting to make a lot of sense. And I said, yeah, for those that stick with it, there can be a real blooming period, like when a plant or a flower blooms. So if you guys are kind of feeling in a fog, just keep at it. You can rewatch these lectures. You can always rewatch Saul's lectures, and it will come to you. So I encourage you to be brave and stick with it. Well, wow, we're at 41 minutes, and I wanted to do something fun with y'all. Before we go on, is there anyone that has any questions whatsoever? And Sai, thank you. I don't want anyone, I love what Sai did. He had some knowledge, he was just thinking ahead. And Sai, you're spot on. This cosine of the angle between the vectors, it does strongly relate to the dot products. We're just not ready to go there yet, but you'll be able to relate this to that in future lectures perfectly. But are there any other questions, and any questions whatsoever? Even the meaning of life. The answer is 42. Okay, explain the loop again. Yes. Oh, I've got one in the chat, and then I'll take the audio question right after do that. So Aodeji is asking, could you please explain the loop again? Absolutely. Okay, first of all, and I probably did go through that fast, sorry. The range statement. Again, oh, here we go. Yeah, if you hover over it long enough, now usually it's just range stop. And that means it will go through values. You know what? This would be even better. Let's do this. Let's first go through the range statement, because this is great for you guys to know. Let's see if it'll do it this way. I'm going to convert my range statement to a list, and don't make a big deal out of this. You know what? I'm trying to be sensitive. Let's do it this way. For I in range, let's just do this first and see what happens. And when I tell y'all, like when you see some code and you're like, what's going on? Well, just break it down, like do silly little experiments like this. This is a great way to learn it better. Okay. Oh, that tells me a lot about what range does. First of all, it's what's called an iterator. It creates something just long enough to be iterated through. So this won't stick around. It's really just to create values for things like for loops. But if I do this for loop and I'm grabbing values from this range statement, look what it did. It went from 0 to 4, but it didn't include 5. So if I want 5, I can do this. I could have said 6, but I think this is more explicit, and boom. Now, well, okay, but what if I wanted to go in other steps? Well, let's do this. Let's include 10. Let's be really explicit. I'm going to start at 0. And then I'm going to step by 2 instead of, well, let's first prove something to ourselves. Let's make sure we get exactly the same thing when we do this. Boom. Okay, now I want to switch it up just a little. I want to go up to and include 10. That's why I'm adding this one, but I'm going to step by 2. Boom, just what I expected. Now, let's do what we were just doing a minute ago. Let's go from -10. And how do I know that? Because I said finite span is 10, and that's what I put in all these statements. But I just want to step by 1. So that's the default value for step. Let's see what we get. -10 to 10, but it includes 0. So I get 21 values here. Now, just for fun, let's step by 4. There you go. Now, like I was saying, this won't hang around. So let's see what this does if I do this. I've never done this, by the way. I'm very curious. Oh, it's just, yeah, you wanted range from -10 to 11 and steps of 4. That's what it returned from this notebook. Remember, the last statement, you can just leave without a print. In fact, if I do print here, let's just see what will happen. It should be the same exact thing with the way notebooks work. Yep. But what if I wanted to create a list really quickly? Well, and just so it's super clear, let's leave that. I'm going to turn the numbers given by this range statement into a list. That's all that means. In fact, just to be extra specific here, let's say, how do I put this? We'll just call it the list. And why didn't I call it list? Because that's a Python keyword. I don't want to do that. So I'm taking this range and whatever values it would have given, I'm converting them into a list. And then I'm printing the list. This is just to really beat home what range does. And boom, there's my list. So if you're ever wanting to be super constructively lazy and just create a list really quick, for testing code or something, you could do something like this. And there you go. All digits from 0 to 9, 10 digits, including 0, of course. So that's all that's going on. But so that if I wanted to change what my finite span was from negative to positive of that span, the reason I'm doing this, well, now I only have to change it in one place instead of 8 places. And a quick trick, I'm going to do Control-Shift-L, and I get all 9 places where that is. So if I was thinking, I don't like Tom's long variable names, I'm going to call it thin SP. And then, you encounter another friend that, is into very clear coding, and they said, that's not clear. And then you go back and go, oh, I should have done it the way Tom was doing that, was Control-Z, changed them all back. Anyway, that's the only reason I'm doing this, so that if y'all had said, oh, fun, let's do it for 12, I would have been ready to do that. So now I wanted to look at all the possibilities of values for I being -10 to 10, and J being -10 to 10, and K being -10 to 10, and L being -10 to 10. Well, that creates all permutations, all possible combinations of these being those. And I get the result one time and do that check. And I'm only looking for one failure, that it didn't hold one time. That means this was not true. It's not true for all cases. And so it was just my brute force way of checking the Cauchy-Schwarz inequality. Okay. Now, Ayodeji, please be persistent with me. Did that do it for you? Or is there still something else here that I could say that would help you?
So I wanted to understand I know the count plus equals to 1 says, okay, when this first loop goes, okay, this is -10. When -10 goes, you go to -1, that's a count gone, right? Okay,
Oh.
so
Now you understand this, right, Ayodeji?
yes.
Okay, good.
The result part, the one where we have the vectors in them, and I want to just understand how the loops are all working together in that.
Sure. Yeah.
Place.
For each one of these times, now the L is changing the fastest. And then the K, the next fastest, the J, the next fastest, I is changing the slowest. So what happens is just saying, I'm going to start at -10. And then while that's held at -10 for I, I'm going to look at all the cases for this. But while this, and I'm just talking about like the first loop or the first set of loops. When this one's -10 and this one's -10, I'm looking at all cases from -10 to 10 here. But when this one's -10 and this one's -10 and this one's -10, I'm going ahead and looking at all cases of -10 to 10. That's what I meant. So when you look at nested for loops, the one that's the innermost for loop is the one that's repeating the fastest. And then it goes to the next one of this one, and it repeats all the way through this one. But while out here, these two were still stuck at, let's say, the first one. But when you're out here, this one, while it's stuck at -10, this one's going through all of those, and this one's going through as many of these times all of these. And so that's what's going on. So over here, this one's changing the fastest. And then this one's changing every 21st time this one changes. And then whatever 21 squared is, that's how frequently this one's changing. And every 21 cubed, that's how fast this one's changing. I hope I'm not throwing too much at you at once, and I can appreciate it. But oh, okay, good. That's what I was hoping for. And by the way,
we have Noreen. Noreen has a question.
Okay, I'm going to do one more thing for Ayodeji, and it might, it's great if we make this stuff super obvious for each other, but let's just do this. For I in range, let's do something small so we can see it real well. In fact, I'll do it even a little smaller so it's easier to see. Now, for J, typing too fast, range 3. And then let's just do this, Ayodeji. And this is what I mean. Just show yourself this stuff until it's crystal clear in your mind. It'll make you a better coder too. Now you see, this is what I was trying to say. While this one's stuck at 0, we've gone all the way through the cases for J. And while J is stuck at 1, we've gone all the way back through all the cases for J again. And when I is stuck at 2, we've gone all through the cases of J again. Now, just so we can see it all, again, we were doing much bigger sweeps down below, but for K in range 2, and again, we're just doing it small, so it's just easier to see it all. You can see again, yeah,
White space.
Yeah. Yep. So there we go. We're only going 0. This is binary now, right? So we're actually counting in binary. Here's 1, 2, 3, 4. But let's look at it this way. It's repeating the fastest here, and then repeating half the speed here, and repeating 1/3 the speed here. So did we beat that to death good enough, Ayodeji? I just want to make it super clear for you.
Yeah, absolutely. Thank you so much.
Oh, you're welcome. Okay, someone, you go. Who's next? Letter.
Naren?
Just ask.
Yeah, I was wondering, will that count variable hold its previous value once it exits the loop, the innermost loop, or it
Right.
refreshes?
Great question. It could only refresh if I had something that would reset it somewhere in here. So look at what happens. I'm putting it inside the lowest, the innermost for loop, so that it gets counted for every single occasion. And so, yeah, it will hold its value once we finish all these for loops and tell me what happened. Now, that's a good point. If it failed, if result not equal this, then we're going to say it failed. And what we could have, a better way to have done this, I was just trying to make it very clear and very quick. But what we'd really like to do is say, oh, I just want to break out when it fails. But what I did instead, I just wanted to see if the check wasn't true for the Cauchy-Schwarz inequality. I want to see the cases. I want to know when it failed. Now, just for grins, let's see where we can make this fail. Let's push it to 9. So what I'm going to do, I hope this is helping. I think it's important, even if some of the students are going, oh, this is so obvious. That's good if you're at that point. But let's bring our other classmates along too, because I guarantee if we bring them along very carefully with us now, they will help us in the future. All right. We just all think a little differently, and that's why we need each other to increase our perspective. So I'm just going to say, oh, it held for all the tests at 9. Now I'm just saying there's going to be some problem in the computer where this won't hold anymore. And we'll get a bunch of things saying, you know, oh, it failed for this case and that case, but we've gone all the way out to 12 places. Now let's go another thousands. And I forget the names of this level, but it's probably something like Pico. It will eventually get it. There we go. Look at all these cases. So I'll let that finish filling. And you see, this is just round off stuff. That's all that's going on. Look, well, 96 point all these 9s compared to 97. That's equal. This is just computer issues. And the 107 point, I mean, we could look through all of them, but we're just going to keep seeing the same thing. So I'm going to delete that and just say, okay, there was the limit. Let's go back to 12 and say, dang, the computer's doing awesome for, you know, dealing with binary and dealing with Python. That's great. Yep, that we can have high confidence that it's holding. Now, I might have gone through some of that too fast, and I'm sorry if I did, but any other questions here? Because I want to, if y'all are good here, you're good for a lot of things moving forward. What do y'all think?
Thank you, Thom.
Okay, good. You bet. Now, most people have enjoyed going past the hour, and it's because there's many personal reasons that Gaita and I have had to put the pipeline class on hold, but we completely intend to finish it and to start teaching it again, but better this time. We learned a lot the first time, and we're going to teach it better the next time and make sure the people that went all the way through get a certificate too from a valid university in the world. But I'd like to keep going if everyone's good with it. We still have almost everyone. I think we've lost one person. Might have been a connection thing, but would you guys like to see a demo of Visual Python, which we'll be able to use for things like Cy was asking in the near future? Would y'all like to see that, or should we take a break? Because it won't take
Yes,
long.
absolutely. I would like to see what I was asking. That was very interesting, actually.
Oh, good. And then were there any, thank you for that. Were there any other questions, guys? Okay, good. And it's okay if there are. I want y'all to know, I appreciate that y'all appreciate my teaching and my mentorship. I have a dear friend in India, Northern India, Arpit Singh. He's got a huge following on LinkedIn, really cool posts. But he did a post recently, and I put it in family chat. And it said this: there was this guy on a stage, and there was a huge projection screen above him, and the slide said, "Be the person you needed to be when you were younger." And I remember so many times when this kind of stuff was new to me, and someone would blaze through a question or not remember what they felt when they were watching a good coder try to explain things to new coders. And sometimes I remember when I was new at coding and I'd go to a site and they would show this really complicated example. It was almost like they were showing off. And I'm like, no, I just need to understand this one little principle. And I want to be that for you guys. So if you ever feel like, Thom, could you bring that down to even a lower, simpler case? You saw how I was struggling to not rush off to converting the range to a list right away. And I felt like, no, you know what? If they see this simple case of the for loop, they'll get it now forever. But I need y'all's help too. Don't be shy, and everyone be nice to your fellow classmates. When someone asks what may seem to you to be like a question that's too basic, in my opinion, it's never too basic. If we leave you behind now, we're hurting ourselves in the future, because that just may be your weak point now. But if we make you strong now, then we're in the future. You may be the very one to help us understand something better in the future. But if we leave you behind now, that ain't going to happen. And we don't want that. That's why our classes are more like a family helping each other. So I really want this environment to be so comfortable that you have no fear asking any kind of question. That's the level of support we want to have for each other. So, and I need your help to encourage new people with that too, because you may know them better than me. They might not know me well enough and think, oh, Thom will make me feel like an idiot if I ask this question. No, Hugo will get on to me if I ever do that. And I begged him to do that. So I don't ever want to be that way, because I know how that feels to ask a question and then be looked down on by the professor. Yeah, that's happened to me and I didn't like it, but I persisted and I went on and learned it better anyway. All right, good. And you're welcome, Noreen. All right. Okay. Now, be prepared to have more fun than you should be allowed to have. I've been using Visual Python for over 20 years, and I'm just still shocked that it's not more popular. 3D, it's even, well, I guess, yeah, 3D programming, 3D visualization programming for ordinary mortals. And the guy that invented this, he's thinking brilliant. And I got to meet his physics professor. His physics professor, and I think his wife, they came to Boise and they wanted to meet me. And it was because I was contributing some modules to Visual Python because I loved it so much. And they kind of wanted me to take over the management of it. And at the time, I was still pretty new to Python, and I was like, oh, I don't think I'm your guy. And I'm sharing this story for a reason. I wished I'd have said yes, but would you help me? You know, just occasionally give me pointers and stuff, because I know they would have said yes. But I wished I'd have taken over Visual Python and been its manager, supporter, and gotten to be friends with the guy that created it. But they're still doing a good job with it. It's just that I could have been the Visual Python guy, and I was too chicken. And I'm saying, when a hard opportunity comes your way, don't turn it down. If it's something you think, well, yeah, I'd like to be that guy or that gal, but I don't think I am that. Don't do that to yourself. Just say, I want to do it, but can I get help? And you know what? Now that I look back, that was my mistake. I could have just said, every time I release something, please give your feedback and make it constructive. I'm just a mortal, you know? But anyway, this is super cool. So now the code to do this is super simple, but I'm going to run this. You guys could do this or something very much like it in just a few lines of code. And so now they've set it up so that you can just do it right in a website. But let's go look at some examples. And by the way, you can go through here and figure out how to install this for your operating systems. So let's go through some examples. Now, if you guys saw my DSGO presentation on integrating brilliance, I actually did some Visual Python simulations that I created videos of, and I might be able to dig those up. I should have thought to dig them up, but I can get them in a future lecture too. So look at this. Now, what's amazing, look how realistic this is. Oh, and I can, wait a minute. I'm trying to figure out which, there we go. Now I'm rotating it while it's dynamically moving around. But these springs are actually expanding and contracting in here while these balls are rigid. And all I'm doing is the right mouse button and dragging it around to look at it. So this is just a simple mechanical model of atoms connected by interatomic bonds. Okay, let's go back to another example. Oh, you can do some realistic texturing too. And we could have made this look like granite or wood or whatever you wanted. And you can see how it's working with the lighting too. Okay. Let me find. Now, there's something in here I want to show that's related to the kind of work we will use it for, but you can use it for tons of things. If any of you have seen any of my old reinforced learning LinkedIn posts, you'll remember that I used this to create my own virtual environments for my reinforced learning agents. Let's see. I wanted to see, there's one for cross products of two vectors. Strong text, stars, Stonehenge. Well, here's a good textures example. Oh, latex math display, that would be fun. But you guys can come back here. Just again, Google search for Visual Python. I was hoping to see that. Well, this will be good too. So when I was teaching control system design at the university level, I had my students use this to animate the control of an inverted pendulum. And again, want to see it at a different angle, what's going on? No problem. It would be very hard to do
Can
this.
we use the code, Thom, just you were explaining here, and see what it gets plotted as?
Let's do that. So what I'm going to do is let's go back here. And let's do the documentation. And it's really good documentation, in my opinion. And you can go through it like this. You can just do a quick overview. You can look at these various things. Now, we'll use this arrow object a lot when we're visualizing vectors. And it's really good for visualizing vectors. In fact, I had debated whether we should start with this or not. And I thought, no, it'd be good if we figure out some tricks to use in with Matplotlib and Plotly, and we haven't used Plotly yet. But you can create your own little control areas and stuff. But let's see, it's got a Spanish version too. I don't know if we have any Spanish friends here. Let's go through this basic intro. This is really good, by the way. You can get really far this way. And we're going to do a little bit of code together here right now. I will bring open Visual Python. I'm going to put this in a specific place, so I'll show you all what I'm doing. Here, now I'm in Linux, so don't let this scare you. I'm just going to create a new file window and then put that back where it belongs. And then I'm going to go to a place on my system where I like to keep stuff for you guys. So this is my cloud drive. I use pCloud. And then I've got 2 terabytes for life. I'm going to go, this is where I keep all my mentoring stuff, but there's a place, now I'm forgetting, oh gosh, I hate when I do this, stuff, if I put it there. And I'm forgetting where I put my stuff for you guys. It's because, oh yeah, I need to create it anyway, because I have been putting most of it into Google Colab, or the Google Drive. The link that Yuko shares with you guys is from there. So I'm going to go into mentoring. The messages that I send out to everyone that joins our family, I keep them in here. You can see my top student. He's so good. I saved some of his stuff. I hope you saw his message in family chat. We were all worried about him, and it turns out his whole family got COVID, and that's why we haven't heard from him. Plus, he's been doing a lot of other things. So I've got a brand new directory here, and I'm going to go back at this level. Now, when I'm in Linux, this is how I tend to open Visual Studio Code for a given directory. So you'll notice when I open that, and I open the window somewhere else, I'll bring it over the top here. And I'm just going to leave this here, and we'll flip back and forth. So I'm going to go ahead and minimize this for now, close this initial message, and I just want to create a new file. I'm going to call it ballbounce.py. Okay, how are we doing on time? We're doing great. Oh man, thought it was later than that. Now, forgive me for a minute. Well, I'll try to keep them. See, I'm sharing the whole screen, so we can get away with doing this, I think. We don't need this code window very wide. So one nice thing about VS Code is if you need more real estate, you can just turn off this area. And so that way I can make this a little narrower, and we can still see all the, as much of the web page as we want. So the first thing I'd really like to do is just create an object. It's got no dynamics. So let's do this. Let's just be constructively lazy and create this ball. Oh, but that's not going to work. Why? Because I need to import visual. Yeah, it's called visual. And then, oh, now there's a problem. I create a virtual environment, so I'm not using my system environment. And I'm going to get my standard virtual environment that I do a lot of stuff in. And oh, that's regretful. I'm going to save this. I just want to make sure it's actually getting that module. So I'll close this. Oh, save, yeah. And then now that I'm in this virtual environment, I'll open it back just to make sure, okay, there's something wrong here because I am not getting visual imported. So I just want to run this much of it to see if in fact it is a problem. If it can't find visual, it could be that it's there and we're okay. Okay, for some reason, I don't have visual installed on this environment, and that surprises me because it's been a while. But let's do a search together. I could find it here. Getting started. Let's see. The canvas. Well, I'm going to be constructively lazy. I'm sure I could find it in this documentation, but I know from skill how to install visual visual Python. And is it showing up? Oh man, that's regretful. Wish more people know about this. Okay. Okay, now it's saying something about Anaconda. I don't really want to do that. Here we go. Well, there we go. That's all I need to do. So it can even just copy it here. And what's nice is in Visual Studio Code, this is already a terminal and I'm already in my virtual environment. So I will just paste that right there. And that could have been Control V. I used Shift Insert, the old way to do it. And now I'm just going to pip install that. And it had most of what it needed already there. So let's just run this again. Oh, and just so that we see that warning goes away. Oh man. Well, let's try it. Maybe I'm importing it wrong. No module name visual. I wonder, let's look here. There must be from oh gosh, Tom, it's vPython. I probably already had it installed and was forgetting that that's how I needed to do it. Yeah, that's all that's going on. Silly me. So that's what we wanted to see. Boom. Yeah, no problem. Okay, now we want to create this ball. Now this will be very interesting. Now notice, why am I having a problem here? Because it's saying, well, you want to import everything. I just don't like that. I'm going to say import vPython as VP. So we just got to be careful to remember that's what we did. So each of these statements that is underlined, they're saying, I don't know what you mean by that, but watch what happens. VP.sphere. Oh, now I know what you mean. From Visual Python, the Visual Python alias, just like NumPy as NP. Well, now, oh, you don't know what a vector is. Well, I want you to do a VP type vector. Oh, you don't know what the color is. Oh, I want you to a VP type color. And now all those squiggly lines, warning lines have gone away. Boy, I went too fast. Let's check one of those. Let's check it at this level. I want y'all to see this. Well, what does that mean? Oh, sphere, any, is not defined. That's all that was going on there. Now, some of you might be using different integrated development environments. Oh, you go. Why didn't you get on to me? This is way too small for y'all, isn't it? Okay, here we go. It's hard to get onto Hugo. He's the most caring guy in the family. All right, now, when we run this, it's going to show up in one of these web pages behind us. But what I'm going to do is shrink all of this stuff so we're only looking at our two screens here. And since I was last looking around in this one, I can go back here now. And when I run this, watch what happens. Oh, it opened it up in the web page. And there's our sphere, our ball. It almost looks a little eggish, but it is round. It's just got perspective to it. So I'm going to go ahead and close that. Yeah, literally open it up as a web tab. And let's give us more real estate here. So we've got the ball. Wow. Well, let's do more though. We've got the ball, but let's get a red box. Let's get that red box thing. And let's do it first. And notice what's going on here. Some of you may be thinking, Thom, why didn't we start with this? This is amazing for, visualizing things. And I would take that criticism and say, sorry, I just wanted you to know how to do it without Visual Python too, because it just takes more to get it installed and stuff. Let's see. Okay, good. Let me know if there are any questions. Now, I just want to make this a little bit more readable because it's new. It's going to get a little busy. So we've got the box, and I'd like to line these statements up. Oh, I didn't mean it. There we go. And these all line up very cleanly. So each of these parameters that we're sending in to these statements for these objects, these visual objects. So what's going on here is the position vector is telling it where to put its center. And so this is X is along, oh, let's look at this picture because it's telling us. So X is across the screen for starters, Y is vertical, and Z is in and out of the screen. Well, there's no reason for us to have this 4, so let's make it 0. And let's make this 0. And so I really want the red box at the origin of that, but yeah, we can put the ball above it in the Y. And we don't need this sticking out, so we're just going to put those right in the plane. We're not going to come out yet. And let's redo these, and let's have a blue ball. All right, here we go. It opens up, and voila, we've got what we'd hoped for, and we can rotate it and look at it. But I'd like this red box to look more like a floor. So I'm going to close that, go back here, and well, the ball has a radius, so that's easy. But here we've got the size. Well, again, this is along the X. So we're just at the very center of the view plane of the window. So let's make this thinner. There's the height, and let's make it flat. In fact, I'm going to make it 12. It's going to be more like a floor. And I can put fractional values here, or decimal values. Now let's look at it again. Oh, nice. Well, let's add some physics. Now, just so y'all know, my origins come from physics-based modeling because I have 3 degrees in mechanical engineering. So hopefully that would make sense. But let's go back here and let's see what we can do. Oh, here's where it gets fun. You get to call these directly. Cross, dot, norm. Said, Thom, you made us muscle through NumPy. Yeah, you're going to be glad you did that. But when you just need to visualize it, this is key. And just to save time, because it's hard for me to lecture and think at the same time. That's why it's good for me to do some prep. But let's do this just for fun. Let's do vPython. And then let's just do bouncing ball code and bounce example. And And there it is. So I just want, we've already been doing this, by the way. And so we've done some sorry. Now, this is not using physics. It's just saying there's some velocity. It's a vector. And we'll go ahead and get this code so that I don't make us wait too long. Again, I could have thought this out, but when I'm having to try to really concentrate on explaining everything as clearly as possible, that would be problematic. Now, let's remember, one and true in Python are the same, but just to be more obvious, I want to say true. And then rate, what's it struggling with? You guys already know, it needs a VP. And let's see, let's call this, well, just to be safe, we'll call it floor. I don't think it's actually using that here, but that's okay. Okay, so we've got vp.rate. Now, look at what's going on here. This will go on and on forever until we stop it. So that's what that while loop means. And this is just a rate, how frequently it refreshes the screen. Now, ball.position, we could have said plus equal, but let's leave it very explicit like this. Plus vol velocity times dt. That means how much in time are we going to step by? Well, it's right there. So that literally is just a time step. Now, if ball.y is less than ball.radius, okay. This is a position on the screen. This is grabbing the y vector. And I want to be careful here because we've been doing it a little different. Radius equals 1. So they were putting the floor at, okay, good. We're putting our floor at position 0, 2. So what this is saying, if the ball vertical position is less than the ball radius, because that would mean the radius is coming to 0, 0. Now you'll notice it's going to go through the floor a little bit this way, and we'll fix that. But then if that's true, ball.velocity.y equals the absolute of ball.velocity.y. Oh, good, they are using physics. Here's the gravity. The way they're updating the velocity, they're giving it an initial velocity, actually. Let's do this. We're going to cheat. We're going to start from rest. Oh, no, I'm sorry. Ball.velocity. Where, and oh, cool. This is actually digital integration. This is calculus. Boy, but that looks simple. Yes. We'll go into this more later. But this is just saying, I'm going to convert the current velocity to a step of position change. That's all this is saying right here. And if you don't understand it, it's okay. But this is literally converting it to a tiny step size and causing position to change a little bit. This is just inverting the direction it was going. And this is letting gravity affect everything. But I don't want an initial velocity in this case. I want an initial position. So, well, I tell you what, let's start with this. It's giving it an initial velocity. Oops, you need that. It's giving initial velocity, but we're going to change it after we get this working to an initial position, like just a height. But the initial position is controlled here. It's 7 above, and it will start to drop, but with an initial velocity. So let's see if we get any errors or not. Oh, well, oh, here we go. If attribute sphere object has no attribute y. Oh, this might have been some old code. Let's see if we can fix that. Okay, let's do a little trick here for figuring this out. wonder, trying to think, ball dot velocity equals a vector, but it's complaining about ball dot y. Ball dot y, ball. Okay, we just got to go figure out how to affect. I thought you could do this. I'm forgetting. It's been a little while since I last used it. So let's do this. And we're doing okay on time. So I'm going to go ahead and close this. And I'm going to say vPython. I'll just use that again, attribute error. Nice. Someone's already had to deal with this. So here's the question. You guys make sure I upvote this if it helps us. Just see if we can short circuit here. Oh, looks like it gets a little more complicated because they're using it as an object. Please be patient with me. Well, let's test something. Before we go in here, I did control slash, just so y'all know. And then let's see, we'll maybe. Let me test this, what's in my brain first. And thank you, Kelvin. I just want to see, can I print ball.y? I mean, I could go look up some old code, but I don't want to take too much time looking for it. It's going to open this when we don't need it to. And I just want to see, no, okay. But if we do this, this should work, I think. We'll keep printing it out though, that's the problem in that window. Okay, that's great. Look at this. We're getting the position here. And that's all we were trying to get by the dot y. So I wonder, can we, I don't think we can, but let's see if we can reference that. So, oh, good. We can just close it that way. Yeah, when we kill the terminal, it kills what was over here. Okay. Okay, it's not subscriptable. Not subscriptable. So, but I bet, now this is a bit of a hack because we're doing this on the fly, and I should probably go look up another reference too. Let's do this and see if we can get it. So notice I close the terminal there and it closes that window over there. And oh, vector object is not iterable. Okay, we need a way. Let's go back to this example. This is somehow gotten outdated, unfortunately. So, well, let's see if the velocity is also a problem. I didn't expect to run into this, guys, but I hope y'all don't mind us troubleshooting together. So let's do this this way. Y. See if we're having the same problem there. It could be just a small, simple update we have to do.
There's a suggestion from Kevin.
No, I saw it, and I don't think that will help us, but I appreciate it. Oh, look. So we're getting it here. What is the difference? So this has been defined as a vector. I bet it was, yeah, here's what's wrong. I bet this is going to work, guys. I bet it was just a little bit of an error. So let's see. I'm going to go ahead and close this so it's cleaner looking. I bet this will do it. Yes, that's all we needed. So when it was trying to say ball.y, we really needed to say ball.posist. That makes so much more sense too. So where else did we have ball.y? So now we know that works. That was so simple. That's great. And I love that because that makes everything a little bit cleaner too, right? So let's step through it again. This is our time step for the physics part of it. And great. So if ball.position, yeah, that we're just changing the position. And now we've got this as the position.y. Yeah, we should be good to go. So let's hope so. Aha, boom. Now I think too, I was wrong about, it must be positioning this floor a little different than I expected. So that's good. It's a really thin floor though. It could be that it is going through the floor just a tiny bit, like, but it would, yeah, it is actually. I can see it now. If you time it, when it's timed just right on the frames, you can see it flattening out there, and we don't want that. So how do we get rid of that? Let's just think about this a minute. So they just made a little bit of a mistake. Is less than ball radius, and we're going to hard code it this time. Is less than ball radius plus. Now what we want is the floor dot size. I hope this works. Dot y. But we want that divided by 2 because our floor is centered at 0. So that means half of it is above 0 and half of it below 0. So it's the ball radius plus half the floor height. And then we're just saying, okay, when that's the case, invert the velocity. So let's try that. I think it'll work. Yeah, that, and if we, so I'm going to rotate it a little bit, and then I'm going to zoom in on it too. And let's get it just right. Yeah, it's just like a steel ball would hit a hard steel floor. That's very elastic, and that's the way it's acting now. All right. Pretty cool, huh, guys? So we're at a good stopping point, but I want to take any questions so far. And I hope y'all will load this and start playing with it. But any questions before we go? Is it as cool as I
Well, these
promised?
are all
Go ahead.
Are these built where we can play around with the values?
Oh, yeah, yeah. You can play around with all these values. In fact, strongly encouraged to set these to variable names, each of these things in here. When I'm doing this for a big project, a big visualization project, I'll have value names for these outside, and I'll put them in classes, and I'll do it up so it's very reusable, very flexible. But for just an initial example, yeah, you can change all of these values, and you can mess things up really good. I know I do. Any other questions? Okay. Oh, good. I'm glad you love it, Hitesh. Now, just so you guys have this, let's see, what's the smartest way to do this? I think it'd be smartest. Let me show you all exactly what I'm doing here. I'm going to go to our Slack, and I'm going to go down to tech chat, because that's what this is. And I'm going to say linear algebra students, our vPython ball bounce code. And then I guess I'll just let's see, I think, yeah, attachments. So I just want to upload from computer. And then thankfully I put it in a place I knew I'd remember. Mentoring, linear algebra, ball bounce. And there's that Python code. And then you could probably put this up directly on YouTube for this session. Wow, why is
I'll do it.
there we go. Great, thank you for doing that. And there it is. Now you guys have access to it. I think this will be a good way for us to share it directly from in here. All right. Any other questions before we take a little break before mentoring? All right. I'm going to take that as everyone's super excited that they learned this. Oh, shoot, let's do this too. History, bounce example. So I'll put these also in that right after that message. And go home here. So y'all have this. You just go back to the introduction, which was down here. And this tutorial is really good too, right here, guys. But we'll just get the main page. And then, all right. Well, any last things? Go ahead and get ready for other things here. The actual notebook that y'all have access to, I'll update it with these changes we did. But I hope you'll, again, make your notebook unique to you. And with that, I will stop sharing and come back over here. And you guys ready to go?
Absolutely.
All right, everybody. I hope this was super helpful. It's going to keep getting better. That's the wonderful thing about learning. If you learn really well these basic things, it's going to keep getting better. This class is a class I've been wanting to do with others, and we are going to grow a lot together in this class. So super excited. I'll be kind of glad. I think you guys will get to a point where you'll go, can I do the next lecture? So yes, you can. And I'll help you with it if you want, but I'll also be very quiet. And I don't want y'all to be afraid to do that. It's a good thing to throw yourself out there that way. Noreen, I see you off mute. Did you have something?
Yeah, this is my first session. Did you have more session before this?
You go, we'll share the YouTube channel in the chat. You can watch the previous lectures, except for the lecture that shall not be named, because it was an abomination. We tried something new. I tried, and it was abysmal failure. And that was, Thom cannot lecture and think about latex at the same time. So we just agreed that Thom will not real-time code the latex, but he will real-time code some of the Python. But yeah, they're all the past lectures there.
And when will
Noreen,
be the next lecture?
oh, this same time next Saturday. But the reason
Okay.
it's good that we're only meeting once a week is because we're encouraging you to watch all of the video lectures. So at the top
Yeah.
of each section of the notebook, I've even taken the time to link all of the videos, but you really only need